Hi everyone, this is HM&S video number 67 and you are most welcome for it. Today we want to talk about how to get geometric mean in Excel. That is the most important mean when you have percentage changes. If you have a data set like this one, we have the number at the beginning of the period and then the number at the end of the period. We want to get the mean gross rate or the average gross rate. The arithmetic mean cannot help us to do this, but when you use the geometric mean, you can actually get the average gross rate. Also, when I scroll down, I have this data set here. It's showing the gross rate per annum. In the year 2021, the investment grew by 15%. Then in the year 2022, it dropped by 13%. If you want to get the average gross rate for a situation like this, a number of people do make mistake by doing something like equals to average, tap to select it, then they get the arithmetic mean just like this. This is actually very wrong. You shouldn't do this. You should use the geometric mean if you have percentage changes like this one. We shall see the reason why you should use geometric mean instead of arithmetic mean when you have percentage changes. Let's switch on to Excel and we dive deeper into how to get geometric mean. Now the geometric mean is always used when you want to find the average compounding rate, or if you want to find the average of percentage change. Can be percentage increase or percentage decrease. Also, before we even start talking about the geometric mean, we should know that the geometric mean is always smaller than the arithmetic mean unless all the rates are the same. That's when the geometric mean and the arithmetic mean will also be the same. Now for students who might be watching this video, or some people who might find it very easy to understand things mathematically, this is how the geometric mean is actually expressed mathematically. The geometric mean is expressed as the nth root of the product of 1 plus the gross rate minus 1. This first formula here is used if you have the individual gross rates. Now in Excel we have the square root function, but we do not have any other root functions. So in order for us to get the nth root, we need to get the product of 1 plus the gross rate, then we raise it to the power of 1 over n. And this 1 over n is now standing for our nth root, then minus 1. So this formula here and this formula here is actually the same. Now let's get to know more about these terms. First of all, GR is actually the gross rate. That's the individual percentage change. The 1 plus GR, or the 1 plus the gross rate, has a special name called the gross factor. The gross factor is actually a value that you can multiply with the beginning amount in order to get a future value, or the amount at the end of the period. N is simply the total number of periods. In most cases, it can be months or years. If you have the individual gross rates for all the periods, you use this formula here. But now, in most cases, we're always given just the ending value and the beginning value, or the ending amount and the beginning amount. If you have only those two, then you use the second formula here. This formula is actually getting the nth root of the ending value divided by the beginning value minus 1. Now the beginning value in finance is actually called the present value, which Excel actually abbreviated as PV. That is the amount at the beginning of the period 1 or the first period. Then the ending value in finance is called the future value, and Excel abbreviated as FV. That is the amount at the end of the last period. Now let's scroll down and we start seeing examples. Now this first example is a motorcycle investment example. In the year 2020, we invested $100,000. Now in the year 2021, it grew by 15%. Then in the year 2022, it went down by 13%. Just like that, up to the year 2025. We want to get the average compounding rate for this investment, or we want to get one number that we can use to calculate the ending value. Now first of all, let's calculate the arithmetic mean, and we see the difference between the geometric mean and the arithmetic mean. The arithmetic mean is actually well known as the average. So equals to, in Excel, it's actually the average that gives us the arithmetic mean. As you can see, returns the average or the arithmetic mean. So I'm simply going to hit tab to select it. Then I highlight the rates or the gross rates. When I hit enter, you can see that the arithmetic mean is 8.2%. Now let's also calculate the geometric mean, then we compare the two. So I'm going to click on this cell B40. I'm going to first of all use this formula to calculate the geometric mean. Then later on I'm going to show you how we can actually calculate it using the Excel function. So I'm going to do equals to, I'm first of all going to get the product of this gross factor, that is the product of 1 plus the gross rate. So I'm going to use the product function, tab to select it, and then 1 plus, now I'm going to put all these gross rates at once, and what I'm doing here is actually an array operation. So I'm going to close this bracket. That means Excel is going to know how to get 1 plus the first rate times 1 plus the second rate times 1 plus the third rate, just like that. That's actually an array operation. If you don't believe it, when I highlight this, then I evaluate it using the F9 key, you can see it's delivering for us an array of answer. This is 1.15, that is 1 plus this gross rate, then 1 plus negative 0.13, that's 0.87, as you can see, just like that. So I'm going to control Z to undo that. So the product of 1 plus this array is actually just this part here. I need to now get the nth root, so I'm going to raise it to the power of 1. I'm going to put this in bracket also, open bracket, 1 divided by, now you can simply count tab the number of period, like all these gross rates here. You do not count the first period, because on the first period there is actually no any percentage change. Close bracket, close bracket. Right now if I hit enter, it's going to give me only this first part here. I need to come here and hit the F2 key. So I need to subtract 1 from it in order to get the geometric mean now. So minus 1. Now, since we are doing an array operation, I'm actually using Office 365. If you're using Office 365, you can simply use the enter key. But if you are not using Office 365, you need to enter this using Control, Shift, and Enter. There's actually no need of me using Control, Shift, and Enter, but I just want to show you what you need to confirm to show that your formula has actually worked very well. If you hit Control, Shift, and Enter, your formula will actually be entered into the field, and when you check the formula bar, you will see the curly bracket, which is put at the beginning of your formula and then at the end of your formula, showing that what you have done is actually an array operation. That's if you're not using Office 365, you need to enter it using Control, Shift, and Enter. But if I hit the F2 key, like for me right now, I'm using Office 365, I don't actually need to use Control, Shift, and Enter. I can simply use Enter and I get the correct answer. And if I come back here and check the formula bar, there is no curly bracket. So you need to put that at the back of your mind. You need to use Control, Shift, and Enter whenever you have done an array operation. Now, apart from helping us to move from some begin amount to some end amount over a period of time, this geometric mean also means the average compounding rate for our investment over the last 5 years was 7.6%. Now, we have done this using this long formula here, but you don't actually need to use this complex formula. There is actually a geometric mean function in Excel called equals to a geomean function. You can see Excel is saying it returns the geometric mean of an array or range of positive numerical data. When I see it highlighted in blue, I hit tab to select it. We cannot actually just put in these gross rates the way it is. We need to put in the gross factor. That is 1 plus the gross rates. I'm going to highlight it. Then when I close my bracket, when I'm to enter it right now, I will get a wrong answer, because if I hit the F2 key, we have used 1 plus these gross rates. I need now to do minus 1. So when I control enter, I get the same answer as the one we have got after using this complex formula. Now, in order for us to understand the geometric mean very well, let me first fill in this table. It will also help us to break down this complex formula. Here, I'm simply going to get the gross factor. That is 1 plus this gross rate. So I'm going to do equals to 1 plus the gross rate. Control enter. Then I'm going to copy it down. Now, this is our gross factor. So let me also calculate the number of periods. Now, this number of periods, we already know that from one period to the next period, it's just 1 year. Then also from 2021 to 2022, it's just 1 year. But let me calculate it. So I'm going to do equals to the ending period minus the beginning period. That will give me the number of period. Control enter. And when I copy it down, you can see that all through, it's just 1 year. Now, if you have the gross factor and the number of period like this, you can also use the gross factor to calculate the geometric mean. Let me also do that using this complex formula. So I'm going to do equals to product, tab to select it. We already have the gross factor, so instead of doing 1 plus, I'm simply going to use the gross factor, close parenthesis, then I'm simply going to raise it. That is like getting the nth root now. I'm going to raise it to the power of 1 divided by the number of period. And this number of period, since we already have it here, I simply need to sum them up, since all of them is actually just 1, 1, 1. So I'm going to simply do sum top of all this period here. So I'm going to close my bracket, then I close the bracket on the entire function. Now, if I'm to enter it right now, it will give me a bigger number, so I need to do minus 1. So when I hit enter, you can see I get the same answer. Now let's get the amount after each and every year. Now there is actually a formula here that helps us to get the ending amount from the beginning value if you have the gross rate. It's saying the ending amount or the future value, which is always the FV, is got by getting the present value or the beginning value times the gross factor, that is 1 plus the gross rate. Then you raise it to the number of period, which is also the NPER. Now this NPER is going to be very important later on. So let's use this formula to get the future value or the ending value. So I'm going to click on this cell, then do equals to, we're going to start with the PV or the beginning value, which is this $100,000, then times, I'm going to put in bracket 1 plus, let's assume we don't have this gross factor, we are simply going to use our original gross rate, so 1 plus the gross rate, then I'm going to close my bracket, then we need to raise it to the power of the number of period. So I'm going to put it in bracket, the ending period minus the beginning period. So I'm going to close my bracket, hit enter. Now in 2022, when we are getting the ending amount, our beginning value will now be the value at the end of 2021, not at the end of 2020. So let's do that. Equals to, the beginning amount is this, times, open parenthesis, 1 plus the gross rate, which is this one here, close parenthesis, then you raise it to the power of ending period minus the beginning period. That will give me the number of period. Close my bracket. When I control enter, you can see I can actually copy my formula down and it will work very well. So if I come here and hit the F2 key, you can see the period is okay and then the gross rate is actually the correct one. So in 2025, we have $144,282 if the gross rates are this one here. Now I want to prove to you the reason why you need to use a geometric mean when you have percentage changes, not the arithmetic mean. Now let's come to this table here. In the year 2022, we had $100,000. Now let's see whether we can use the arithmetic mean to get us to the final amount, which is this one here. So I'm going to click on this cell, equals to, if you want to get the future value, we use this formula here. So the present value is this times, I'm going to put it in bracket, 1 plus, now our gross rate is now going to be the arithmetic mean. So when I click on this, then close bracket, raise it to the power of, now the number of period is now going to be 2025, that is the ending period, minus 2020, that is the beginning period. When I close my bracket and when I hit enter, you can see we are getting different answer. You already know that in 2025 we have $144,282. But when we use the arithmetic mean is giving us a value which is more than the value at the end of the period. Now let's also use this geometric mean to see whether it will give us this exact value here. So I'm going to click on this cell, equals to, the present value is going to be this $100 times, open bracket, 1 plus, now this time around we are going to use geometric mean, then close my bracket, then I'm going to raise it to the power of the ending period minus the beginning period. Then when I close my bracket, now when I hit enter, you can see when you use the geometric mean, you get the exact value at the end of the period, but when you use the arithmetic mean, you get a value which is actually higher than the value at the end of the period. Now I'm going to copy this, Control C, and then I'm going to paste it down here as a value. So I'm going to right click, come to paste options here, I'm going to paste using this second option, value. So I'm going to paste it here as a value only. I'm also going to give it all borders, come here, all borders. Now let's assume that we simply have our dataset presented like this, which is, by the way, most of the cases, we always have only the beginning value and then the ending value, and we want to get the gross rate. If you have only the beginning value and the ending value, then you need to use this second formula here. So I'm going to click on this cell, and do equals to, we need to get the ending value divided by the beginning value, then we raise it to the power of 1 over n. That is just like getting the nth root of this value. Then we also subtract 1. So I'm going to do ending value divided by the beginning value. I need to put it in bracket, so I'm going to put this one in bracket, then come to the end. Then I need to raise it to the power of 1 divided by, for the period, I'm going to do the ending period minus the beginning period. That one will give me the number of periods. Close my bracket, then again close my bracket. Then I need to subtract 1. So when I hit enter, you can see I get the same geometric mean. Again, Excel always get us covered. You don't actually need to use this complex formula here. There's an Excel function called equals to RRI. I like calling it the rate of return of an investment, the RRI. So when you hit tab, it has 3 arguments. The NPER, that is the number of period. PV, that is the present value. Then the FV, that is actually the future value. So it's actually as simple as that. We need to put the number of periods, which is actually the ending period minus the beginning period, then comma, present value. Is this $100,000, comma, then the future value is this one. Then I'm going to close my bracket. When I hit enter, you can see it gives us the same geometric mean. So in most cases, when we are doing the geometric mean, we will always not use these formulas here. We will always use Excel functions. So I'm going to scroll down. We have the second example, which is having the computer prices. Now, in the year 2010, the price of the computer was 1,200. Now, in 2024, it went up to 2,000. We want to get the average gross rate. Let me first do the maths way. So I'm going to do equals to, that is using this formula. I'm going to do it one more time. The ending amount divided by the beginning amount. I always forget the bracket. Let me put it in bracket. Then come to the end. I'm going to raise it to the power of, open bracket, 1 divided by, I'm going to do the ending period to get the number of periods minus the beginning period. Close bracket, then minus 1. So when I hit enter, you can see the price of computers grew by 3.7%. Let's also use the Excel function equals to RRI. You see it highlighted in blue, you hit tab to select it. The number of period, ending period minus the beginning period, comma, the present value. This, comma, the future value, this. Close parenthesis, and when I hit enter, you can see I get the same geometric mean. Now let's also prove it whether if we use this geometric mean, we get to 2,000 at the end of the year 2024. So I'm going to click on this, equals to the present value. Is this $1,200 times, open bracket, the gross factor is 1, plus our gross rate, which is this geometric mean, comma, then we need to raise it to the power of total number of period, which is ending period minus the beginning period. Then when I close my bracket and when I hit enter, you can see that with this rate, we get exactly the ending value, which is this one. So I'm going to scroll down, click on this, push it aside. So let me first increase this. So in 2010, we had 250,000 data analysts. Then in 2024, we're having 650. What is the average gross rate between those two periods? So I'm going to click on this cell, equals to RRI, tab to select it. The number of period is going to be the ending period minus the beginning period, then comma, the present value is actually this, comma, then the future value is actually this. Close bracket, and when I hit enter, you can see I'm getting this. This one I've done it using the maths way, and also I went ahead to prove it. You can see it's giving us the same ending value here when we use this rate. Now let's see one more example here. Now let's start by getting this note. It's saying when the rates are the same throughout the period, like for our case here, that's when the geometric mean, the GM, is always equals to the arithmetic mean. But otherwise, the geometric mean is always less than the arithmetic mean. So let's prove that here all the rates are the same throughout the year. So when we calculate the arithmetic mean equals to average, tab, I'm going to highlight this, and when I hit enter, the arithmetic mean is actually 0.15, that is 15%. the geometric mean equals to the geo mean. We are going to use the geo mean function because we have the individual rates there. Top, the number is going to be 1 plus the rates, which is these rates here. Then I'm going to close my bracket and we need to do minus 1. Now, if you're using Office 365, you simply need to use enter or control enter. But if you're using a previous version of Office, then you need to use control shift and enter because we are doing an array operation here. For me, I'm using Office 365. I'm simply going to hit enter. And this one, I've done it using the maths formula, which is this one here. So you can see that if the rates are the same for all the periods like this one, then the geometric mean is always equals to the arithmetic mean. Otherwise, the geometric mean is always less than the arithmetic mean. Yeah, that is it for this particular video. If you haven't subscribed, please do subscribe. And if you found this video interesting, give it a like, then you share it with your friends. This is a video where we talked about how to get weighted mean in Excel. You can click on it, then you go and watch it. Until next video, HM&S video number 68, then we meet again. Thank you.